everyone. Today we are going to discuss about linear programming formulation. We have already discussed about linear programming solved by graphical method, linear programming solved by simplex method. In this class, we will discuss how we can formulate the linear programming. Formulation का मतलब क्या होता है? The verbal expression, what is the verbal way or the word format of the problem we have to make it in the mathematical model form. So as we all know, linear programming is a mathematical technique used for decision making. It helps us to allocate the resources in a proper way. So we all know that resources are always limited, so we have to use it in a proper way. So we use linear programming for optimal allocation of resources. So formulation, what is the meaning of formulation? Formulation is converting the verbal description into mathematical form. And what is the way how we are going to convert it? Means all the formulation problems will be in a word problem like. So we have to convert that verbal description into a mathematical model. So what is the general mathematical model form? First we need to say that. This is the general mathematical model form. M is used, number of constants. N is used for the number of variables. Find x1, x2, x3 up to xn so as to optimize the objective function. Okay. So we need to express our constraint in terms of m. We need to express our variables in terms of n, and we have to find x1, x2, x3 up to xn so as to optimize the objective function. How we are going to write the objective function or the general mathematical model? First, we all know the mathematical expression always have a objective function. It can be a minimization problem or a maximization problem. So we need to write maximization z or minimization z equal to C11 C1 x1 plus C2 x2 plus C3 x3 up to Cn xn. As we all know, C1, C2, C3, Cn, these are our cost associated with all the x1, x2, x3, xn. Subject to the constraints, how we are going to express our constraints? Constraints a11 x1 plus a12 x2 plus a1n xn. It may be in less than equal to or greater than equal to b1. As we all know, b1 is our resources. a21 x1, a22 x2, a23 x3, like this we need to write up to a2n xn less than equal to or greater than equal to b2. Like this we have to write am1 x1, am2 x2, amn xn less than equal to or greater than equal to bm. So this is the general mathematical model, and we need to write what is our x1, right? We have to write x1, x2, x3 up to xn should be always greater than equal to 0. Because when we are producing something, we are making something, then it always should be greater than equal to 0. It cannot be 0 actually. we need to express the variables as greater than equal to 0. Because x1, x2, x3, maybe we are producing something, we are manufacturing something. These are the things. So, how it can be 0? So, it always greater than equal to 0. So, this is our subject to constraints am1 x1 am2 x2 plus amn xn less than equal to or greater than equal to bm. These are our use of resources, and these we have to express x1, x2, x3 up to xn should be greater than equal to 0. These are called non-negativity restrictions. This cannot be actually 0 or negative, because we are producing or manufacturing something, so that never be 0. That cannot be never be 0. So, how we are going to write? What is the C1, C2, C3? C1, C2 up to Cn equal to per unit contribution to variables. The cost or the profit or the loss, whatever is associated to our variables x1, x2, x3, that we need to write in the objective function. So C1, C2, C3, these are the coefficients, and that is per unit contribution to the variables x1, x2, x3 up to xn. B1, B2, Bn, these are the limitations of resources. These are the limitations of resources. B1, B2, B3, B4 up to Bm is the limitation of resources. Because we are going on using, this is the part of the resources as A11, A12, A13, like this we are using in for each variable x1, x2, x3. So these are called the part of resources we are using out of B1. A21, A22 we are using out of B2. Like this we are using the resources from the limited resources B1, B2, B3 up to, this is up to Bm. A11, A12, A13, Amn, the resources used by variables out of limited resources B1, B2 and Bm. And B1, B2, Bm are the resources that is given in the question. That is the maximum resources. So this is the general formation of LPP. Let us take one example and see how we are going to solve the linear programming formulation. Let us take one example. So we have taken one example. So the question is like this: a firm produces 3 products A, B, C, each of which passes through 3 departments: fabrication, finishing and packaging. Each unit of A requires 3, 5 and 2 hours of fabrication, finishing and packaging. Means we are manufacturing 3 types of products A, B and C. Each product of A requires 3 hours to be fabricated, 5 hours to be finishing and 2 hours for packaging. Like this, unit of B requires 4 hours for fabrication, 4 hours for finishing and 4 hours for packaging. While each unit of C requires 2 hours for fabrication, 4 hours for finishing and 5 hours for packaging. In 3 departments, every month 180 hours are available in fabrication. This is the limitation part. Means 3 departments every month 180 hours are available in fabrication. Means in every month we have only 180 hours for fabrication. 6 hours for finishing and 300 hours in packaging department. So every department has a constraint. Means this department of fabrication has 180 hours. For department finishing is 216 hours and packaging 300 hours. This is our limitations. If unit contribution of product A is 15 rupees, product B is 30 rupees and product C is 24 rupees, formulate the problem as LPP to maximize the contribution. So these are our contribution part. Means product A is contributing 15 rupees, product B is contributing 30 rupees and product C is contributing 24 rupees. So formulate the LPP to maximize the contribution. So this is our question. So we need to solve the question. Let us see what is our steps, how we are going to solve the LPP. Let us start. Main first part of our LPP is to identify the variables. What are the variables? Here we need to decision variables. These are called decision variables. Means how many products of A we need to manufacture, how many number of products B we need to manufacture and how many number of products C we need to manufacture to maximize our objective function or maximize our profit. This is the case. So first step of linear programming formulation is to identify the decision variables. So step 1 I am writing is identify the decision variables. Identify the decision variables. Let x1 units of product A, x1 units of product A produced, x2 units of product B produced and x3 units of product C produced. So these are our decision variables. What is the non-negativity constraints? As we are producing x1, x2, x3, these are called the non-negativity. Step 2 is non-negativity. Non-negativity variables. These are our non-negativity variables. x1, x2, x3 always greater than equal to 0. These are because we are producing something. x1 number of units we are producing, x2 number of units we are producing and x3 number of units we are producing, though this cannot be negative or 0. This is always greater than equal to 0. So these are called non-negativity variables. So what is our third step? Step 3 is express the constraints in terms of variables. Express the constraints in terms is our constraint? From the question only we can see our constraint is 180 hours are available in fabrication. This is 180 hours for fabrication, 216 hours for finishing, 300 hours for packaging. These are our limitations. How we are going to write it? So first we need to write it in a box form, all the limitations, so that we can write all the constraints. Step 3. Express the constraint in terms of variables. We have identified our decision variables as x1, x2 and x3. So how we are going to identify the constraints in terms of our variables? So we all know from the question that what different departments are there, like fabrication, finishing and packaging, and we know the processing time of product A, product B and product C. So if we see the product A, each unit of product A requires 3, 5 and 2 hours for fabrication. 3 hours for fabrication, 5 hours for finishing and 2 hours for packaging. This is about product A. Each unit of product B requires 4 hours for fabrication, 4 hours for finishing and 4 hours for packaging. Like each unit of C, product C requires 2 hours for fabrication, 4 hours for finishing and 5 hours for packaging. So what is identified all the constant in the question? In 3 departments every month 180 hours are available in fabrication. For fabrication available time is 180. Like this for finishing 216 hours available for finishing. Finishing 216 hours available. This is in hour. And for packaging 300 hours available. So this is our constraints. Means we need to stick to 180 hours for fabrication, 216 hours for finishing and 300 hours for packaging. We cannot extend or exceed this time period. So this is the expression of the constraint in terms of variables. These are our constraints. We cannot exceed this time per month. So let us write how we can express it, the constraints. So as you know, these are our constraints. So how we are going to write in terms of our variables? Let us see. Fabrication needs per month we need 180 hours. We cannot exceed 180 hours. So product for fabrication, product A is taking 3 hours for fabrication, product B is taking 4 hours for fabrication and product C is taking 2 hours for fabrication. So how we are going to write? As we express A as variable x1, because x1 units of A we are manufacturing, x2 units of B we are manufacturing and x3 units of C we are manufacturing. So how we are going to write it? For fabrication is a constant, it has a time limit. So we can write it 3x1 plus 4x2 plus 2x3 less than equal to 180. Like that we need to write for finishing 5x1 plus 4x2 plus 4x3 less than equal to 216. For packaging, we need to write 2x1 plus 4x2 plus 5x3 less than equal to 300, because these are our time line. We cannot exceed this time, so we have to express it less than equal to form. So this is our constraints. We have expressed the constraint in terms of variables. So how we are going to write our objective function then? Because we know we have to maximize it. So the objective function that is Z maximum equal to, go to the question, the unit contribution of product A is 15 rupees. So 15 rupees is the C1 for X1. Means if we are producing X1 number of products, unit contribution for product A is 15 rupees. Means if we are producing 1 unit, then we are getting a benefit or profit of 15 rupees. If you are producing X1 number of units, then total profit or total cost will be 15 X1. Right? Like this we have to write plus the unit contribution of product B is rupees 30. Means if we are producing 1 unit of product B, then we are getting 30 rupees profit. So if the number of unit is X2, then the total cost will be 30 X2 and product C is 24 rupees. So 24 X3. This is our objective function. This is our objective function subject to the constraints. And what is the non-negativity constraint? X1, X2, X3 should be always greater than equal to 0. Let us put all these things into a form. Okay. So we have done it. We have write the objective function. We have written the constraints. So how we are going to express all the things into one table? So we have to write like this. For the formulation questions, we have to write like this. Find means we have to know that how many number of units of X1 A, how many number of units of B, and how many numbers of C we need to produce to maximize our profit. So the thing is that we have identified the decision variables as X1 units for product A, X2 units for product B, and X3 units of product C. So we need to know how many unit of product A, product B, and product C we need to manufacture. So find X1, X2 and X3 units of product A, B and C so as to, these are our decision variables, so as to maximize Z equal to 15x1, 30x2 plus 24x3. These are our, this is the objective function. Subject to the constraints. Subject to the constraints. Subject to the constraints. 3x1 plus 4x2 plus 2x3 less than equal to 180. 5x1, 4x2 plus 4x3 less than equal to 216. 2x1, 4x2 plus 5x3 less than equal to 300. x1, x2, x3 should be greater than equal to 0. This is our non-negative constraints. So in this way we need to write our linear programming formulation question. So to solve the linear programming questions, after our formulation only we can go for solving the problem by graphical method, or if we are having more than 2 variables, then we can go for maximization method. Simplex method. If we are having only two variables, we can go for solving it by graphical method. If we are having more than two variables, then we can take the help of simplex method to solve the linear programming, as we have already discussed in our previous videos. So for that you can refer the previous videos. Thank you very much. I hope you understood the linear programming formulation problem. If you like the video, share with your friends and subscribe the channel. Thank you so much.